So for today's class, I'm just gonna go over quickly about we started with chemistry, and the first lessons is regarding the binary compounds, and that started with ionic compounds. So in grade 10, we learned about matters, and in grade 9, we learned about matters, and we know that there are two types of matters: pure substance and mixtures. And within this category of pure element, there are pure substance. There are two kind of matters: elements or compounds. So for compounds, it can be further break down into binary compounds and more complicated ionic compounds. And today we're going to learn more about binary compounds. So the definition of binary compounds is that bi it's number prefix for two. So binary compounds means that if you have your compound and you're made up of two elements. Here there are two kind of binary compounds: ionic compounds and molecular compounds. And today we'll be focusing on ionic compounds. So ionic compound means the compounds that are made up of a metal cation and a non-metal anions. So a quick review on the terminology. When we talked about particles, we know that there are atoms and there are ions. So atoms are neutral, ions are charged. And cations means you are charged with a positive charge, and anion means you are negatively charged. So just memorize as remember cation. So it's a CAT, which cat purse, so plus, so cation is positively charged, and the other one is negatively charged. So the bond forms between the cation and anion is called ionic bond. So you only see ionic bond in ionic compound. The valence shell electrons are transferred from the metal to the non-metal. So here, remember metals, remember our periodic tables. So you have all of your metals on the left side of the periodic table, and those are and remember the numbers on top of the periodic table. So if you look at, there are numbers at the very top of periodic tables, which is the group number. So remember, the last digit of numbers is how many valence shell electrons those elements have. So metals are on very right. So for example, group 1 and 2 metals, which means they have 1 valence shell electrons, or they have 2 valence shell electrons. So in that case, remember our stable octal rules. So if they want to achieve a stable valence shells with 8 electrons, the easiest way for metals is to donate electrons. And for nonmetals, usually they are on the other end on the periodic tables. So they are very close, already very close to have 8 electrons on the valence shells. And it's easier for nonmetals to gain electrons to be stable. The overall electric charge of the compounds is 0, because compounds also neutral. So it's like atoms. So when you see anywhere describe this as a compound, it means that the overall charge are 0. So when we later learn about chemical formulas, so if you are given the name of this compound and you ask to write the chemical formulas, so always remember you need to balance the charge of the cations and the anions. some quick, we're gonna learn about nomenclatures of ionic compounds, about namings and writing formulas. So when you have a ionic compounds, let's start from writing, naming them first. So if you have a ionic compound formula in front of you, for example, let's see if we have something like that. So CaCl2 supposed to be a smaller number at the bottom, like a footnote. So if you see Ca, you go to your periodic tables and see which elements is represented by Ca. I can tell you now that is calcium. So and so look at calcium. So if you have a periodic table in front of you, you can take a look at calcium. It's in the group 2. So we learned about periodic table in grade 9. So anybody want to tell me like what does group 2 elements have ionic charge for group 2 elements ion? Anybody? You can answer that in the chat if you want. Okay. All right. So, okay. So as I mentioned, the group number actually tells you how many valence shell electrons they have. So for calcium, it's a group 2 element. So when it becomes an ion, it becomes an ion with +2 charge. So calcium is a +2 cation. But the rules for naming ionic compound is that the metal in the front, it will always keep its name. So it will always have the same name as neutral. So the calcium is just going to be called calcium. And the metal anions, that ends with IDE. So if originally it's no matter what letters, the last 3 letters become IDE. So for example, iodine become iodine become iodide. So chlorine become chloride. So here, the one I put on top is calcium. Okay, I should, well, it's okay too. Calcium chloride. All right, so for ionic compound, you don't need to show how many numbers of each element you have. So we have 2 chloride here, but on the name you actually couldn't tell. Like there's no number prefix or like actual number in the name to tell you how many chloride or how many calcium you have. You have to, if you are given the name, you have to judge that yourself. So that's why in grade 9 we ask you to kind of memorize some rules about the periodic table. For example, group 1 elements always have +1 charge when they become ions. Group 2 elements always have +2 charge when they become ions. So here, if you're given a name, it's like assuming you know that calcium is from group 2, so calcium will have +2 charge, and chloride is from group 7, so it will become a -1 charge anion. So there is you need to balance this +2 and the -1 by multiplying the -1 with the 2. So you have 2 anion with -1 charge. So the overall charge is -2 for anion, and then the overall charge for the cation is just 1 calcium, which is a 1 +2. So when you add it together, it's 0. So overall, this compound has like 0 charge. All right, so metals always go in the front. So it's the same order for the formula and the name. So if you see metal in the front, the name goes in the front. Whatever you see at the bottom, it follows. All right, so always metal always before non-metals. We always write the cation first and then the anion associated with it. Okay, any questions about naming ionic compound? Okay, anytime you can raise your hand and or just post the question directly into the chat, okay? Right. Next, we're gonna try to predict ionic compound using Lewis dot diagram. So the first example we have is sodium and chlorine. If we have a periodic tables, I can tell you that sodium is our group 1 metals and the chlorine is the group 17 halogen. So if you remember Lewis dot diagrams, it's the ones that with the element symbol in the middles, and you put the valence shell electrons, like number of valence shell electrons around that symbol. So it looks like that. So for sodium, because the it's a group 4 metals, means that it only have one valence shell electron. So it look like that, which just a sodium is an A and with one dot on top. that dot should be like directly on the top, but this one is a little bit off. All right, so now it's not at a stable octet rule. So it's not 8 electrons. We have 1 electron. So it wants to lose that 1 electrons to be stable. Because when you lose the electrons, that valence shell is gone because that valence shell only have 1 electrons, and it automatically look at the shell, like the valence shells under that. So that is a full valence. We have 8 electrons. So when you lose the electrons, it becomes very stable for sodium. And let's take a look at the chlorine. So okay, so chlorine should be in the center of all those axes. So the axis represent the valence shell electron for chlorine. And in this case, sodium will donate its electrons to the chlorine. So chlorine actually gain 1 electron to be stable and become anion because electrons is negatively charged. So if you lose electrons, you become positively charged. If you gain electrons, you become negatively charged. All right, and here we notice that it's the electron transfer ratio between sodium and chlorine is 1:1. So the charge actually just balance off each other. Okay. So if you want to describe the situation in word, is that once the sodium atom, because before when we drew this atom, this is an atom, it loses electrons to the chlorine atom, right? So remember, electrons is negatively charged. The chemical name, because it's 1:1 ratios, so the formula will just be NaCl, because it's 1:1 ratio. So this is a C. So this one is positively 1 charge, and this one is negative 1 charge. So if you add 2 together, it's 0. So the overall is 0. That's perfect. It's 1-to-1 ratio. You don't need to do anything. But for the chemical names, Na is sodium, which is metal. It doesn't change. And chlorine, you need to change the I and E into IDE. So sodium chloride. Okay, so naming is really important. You will, if you keep taking chemistry after green science, this is knowledge you're gonna use throughout your high school, as long as you have chemistry class. So the rules are very important. You're gonna have a entire chapters about how to name chemical compounds in grade 11, but you already learned this in grade 10, so some teacher would not teach in details, so you have to kind of know it from grade 10. All right, so the sodium chloride and NaCl. All right, next we have beryllium and oxygen. So berylliums, that's if you have a periodic table in front of you, okay, Google one. Beryllium is element number 4. It's written as Be. So it is a group 2 metals, so it's from group 2. It will have 2 electrons, like that, right? So when you draw it, you can put it on the side, or you can put it on like top and bottoms. It doesn't really matter, as long as you don't pair them up, because now they're lone electrons, they're not electron pairs, so don't pair them up. All right, this is okay. This is okay. If you have that, this is okay, but this is not okay. A pair is not okay, because it has 4 electron shell. The first one has 2 electrons and it's full, and the second one, so if we remember the Bore-Lucifer diagrams, so Be is N2 plus P2, and the first electron level you have 2 electrons, and the second one you have 1 and 2. So they're not paired up together, because the N equal to 2 electron shell can have maximum of 8 electrons. So when you have 2, those 2 electrons will not be staying together. So never do it like this. Okay, don't do it. And it will for beryllium, it's easier for it to lose 2 electrons to be stable rather than gain 6 extra electrons to be stable. So you will lose those 2 electrons. And for oxygen is group 16. So remember, the last digits tells you how many valence shell electrons it will have. So last digit is 6. So we have 1, 2, 3, 4. Once you have over 4, you can start pairing up 5 and 6. Okay, so that's your oxygen is gonna look like. So you can imagine that this electron goes here, this electron goes there, like that. And it will get 2 electrons to be stable because it's 6. It's like it's 2 electrons away from 8 electrons. So it's easier for it to get 2 electrons. So after that, you will have your beryllium with positive 2 charge because it loses 2 electrons, and then you will have your oxygen with negative 2 charge because it gained 2 electrons. The description's pretty straightforward. So it's the B atoms lose 2 electrons to the O atoms. All right, so the beryllium lose 2 electrons to the oxygen atom, and now they become ions. So the chemical name, as we said, metal doesn't change the name, so it's beryllium. And then for oxygen, it's very special change of the name. This is the name that you need to memorize, because for halogen, it's easy because all the halogen, so group 17 elements, it ends with I and E. So it's very easy, like the one we did, chlorine to chloride, iodine to iodide. So it's easier to imagine the change for those elements, but for oxygens, you're actually getting rid of 4 letters instead of 3, so it becomes oxide. So this is beryllium oxide. The chemical formula, since it's positive 2 and negative 2, when you add them together, is 0 already. So it's a 1-to-1 ratio. So BeO. And when you write the when you write chemical formulas, just always remember, if your chemicals, if this element symbol has 2 letters, the first one's capitalized, and the second one is always the smaller case letters. And you need to be like pretty obvious about it, because E is okay, because for E, the capitals letters and the smaller case are looking very different. But for the ones that's obvious, for example, for O, so you have an element called CO. I think it's cobalt, which is a transition metals, but you also have a compound called CO. So this is carbon monoxide. So if you're not careful with your O's, those 2 things, which represent entirely different stuff. One is a pure element, one is a covalent compound, which we're gonna learn later. You're gonna mix these 2 together. So be very careful when you write the chemical symbols for elements that has 2 letters, okay? Be very, very careful with capitals and the smaller case letters. Okay. If I'm learning to speak. All right. So the last one we have is the calcium and fluoride. So calcium is our group 2 metals. Fluoride is group 17. So calcium will have 1, 2 electrons, and fluoride will have 7. 1, 2, 3. Wow, that's a bad habit. We're gonna do it. 1, 2, 3, 4, 5, 6, 7. So you draw it, just make sure that now we have 7s. So 7s is over 4. So, and it's gonna have some electron pairs here. So you can pair up the electrons. However, for this one, so it's alone electrons. The exact location of the alone electrons, you can put it in other place. So you can write it, you can put it on top, or you can put it on the bottom. It doesn't matter. It doesn't make any difference. They're all like fluoride. They're all fluoride atoms. It doesn't matter where you put that lone pairs, okay? All right. So that's the two elements. So calcium, it want to lose that 2 electrons. And fluoride, it wants to gain 1 because it only have one space left. It wants to gain 1 electrons. Then once the fluoride has it, okay, so here you are losing 2, but your fluoride only accepting ones. Sorry. Okay. So your calcium, your calcium will lose 2 electrons to be stables, but your fluorine can only accept 1. So if you have 1 atoms of fluorine here, this one fluorine can only accept 1 electron. So you need another one in order to lose all of those valence shell electrons on calciums. So here you need 2 of them. And looks like that. So you have F in the middle. I'm not sure what happened. So it's like shifted and it's negatively 1 charged. So overall, you will say that 1 calcium atom loses 2 electrons to 2 fluorine atoms. Okay. So overall for cations, okay. So for cation here, this is the cation. It's the charge is overall positive 2, and you have 2 F -1, F -1. Just ignore this F here. So the overall charge for the anion is negative. Oh, sorry. -1 times 2 become -2. So when positive 2 added with -2 overall is 0, so you're balanced. All right, so let's look at the chemical names. So calcium is just calcium. Metal is always the same as you see on the periodic table. Fluoride, it's very nice. They have INE. So if you see INE, just switch it to ID. So fluoride. Right, ID. The chemical formulas, you have 1 calcium matching, pairing up with 2 fluoride. So CaF2. So this numbers, when you write it, it should be like a teeny tiny numbers at the foot of, on the right side foot of the elements, the chemical symbols, because you know the number that's the same size as the letters, so the capital letters has different meanings. We're gonna learn it later. All right. Okay. So let's try this together. Aluminum and oxygen. So aluminum is a group 13 electrons. Oxygen is group 16. So I'll give you guys about like 2 minutes to draw the Lewis dot diagram on a piece of paper in front of you. All right. Just try a little bit. I'm going to tell you one is group 3 and one is group 16. Okay. So the aluminum, which was the letter Al, it has 3 valence shell electrons. So 1, 2, 3. Oxygen, O, is a group 16, so we have 6 electrons. 1, 2, 3, 4, 5, 6. That's 2 spare space. Here, before we start the electron transfer, here, Al will become, if it wanted to be stable, it will lose 3 electrons. All right, so Al becomes Al3 plus, positive 3 charged cation. Oxygen, it will gain 2 electrons. So it becomes oxygen 2 minus. So how are you gonna balance a positive 3 charge with negative 2 charge? So remember, you can always, like, you can add, you can throw in another atoms, or but the other, like if you put another aluminum here, it also has positive 3 charge. So you cannot separate this 3 charge. It has to come together, go together. Same for the 2 negative charge. It has to come together, go together. So when we see numbers like that, that's you don't have any ones, so you cannot just simply multiply with the other number like what we did before. Think about any common multiplier of 3 and 2. So the smallest one will be 6. So let's just multiply 3 with 2. So we have positive 3 times 2, which is positive 6. And then you have negative 2, let's time it with 3. So we have negative 2 times 3 and become negative 6. So when they add it together, it's a 0. So here, that means I will have 2 aluminums and 3 oxygen. All right. So the situation become that a little bit messy. 2 electrons here goes to oxygen number 1. 1 here goes to oxygen number 2. And then you have the last 2 go to oxygen number 3. All right, so this is a little bit all over the place. This is positive 3, positive 3. Of oxygen is 2 minus. Oxygen is 2 minus. All right, so it's called the aluminum oxide. Aluminums, the name stay the same, and oxygen is then turned into oxide, as we talked about before. So the formula become Al2O3. Okay, so always trying to make the number look smaller. All right. Any questions? Yes, no? I'm gonna share another document. We can do a little more practice together. This is really important, how to predict the structures and name the electrons, name the compound. All right, so I wanted to do more practice together. So I got a question saying, would it be called di-Al and trioxide? No, it will not. For this is a very special chemical property of metals. So if you don't look at the transitional metal, which is the block in the middle of the periodic tables, most metals in group 1 and 2, they only have one electron charge. So group 1 will always be positive 1, and group 2 will always be positive 2. Alumina is in group 13. I think it is the only one that's not transition metals there, so it will have positive 3. And during the test for chemistry, you will be provided with a periodic tables, and on that periodic table, some of them will show, like it will show the electron charge. And I don't think there are some cases where the metal can have multiple charge, but it's usually it's no more than 3. So you can have 3 different charges. And in that case, in the NAM, you're gonna show the charge of the metals, but not by ditri, those number prefix, by Roman letter numbers on the brackets after the NAM. So we're gonna learn about multivalent metals later. And for example, if you have ions, so ions is Fe, iron, Fe. It has 2 possible ionic charge, positive 2 or positive 3. So if you ever see a iron in the chemical name, usually it will follow by brackets, and in the brackets it's the Roman number, either 2 or 3. So 2 capital letter I or 3 capital letter I, and that will tell you the charges of that metal ions. So for ionic compounds, there was never a number prefix. You don't need to worry about it because metals has fixed ionic charge. You will always be able to judge the numbers of the metals and non-metal based on the metal's charge. All right. Okay, you're welcome. Just give me some time. I need to pull out document. Take some time, think about the naming rules we just learned. And here we go. Share screens. Not sure. Okay. All right. So the atoms. So here we have a worksheet here. The first column is atoms reacting together. So the ions, the atoms that's gonna form the ionic compound. So here we're still on ionic compound, and charge okay, so the first one we have, it's a metal. So this is potassium. K. So metals can, when it becomes ions, what kind of ions it become? Any volunteers? Okay, so metals always become cations. It's always positive charged. So the cations. And now metals always become anions, so it's positively charged. And negatively charged. They have potassiums. It lose one, become positive 1 charge. Sulfur is in group 6. It's the one up below oxygen, is also in group 16. Potassium is in group 1. Okay, So potassium is 1 positive, sulfur is 2 negative. Here is the imbalance, but we have the magical number 1, so we can just multiply this by 2. All right, we kind of know that we need to multiply this by 2. We have 2 potassium here, each one with an electron on the top, and we have a sulfur here. 1, 2, 3, 4, 5, and 6. So these electrons go here, and this electron goes here. Okay, I think I'm doing the 2 apart from each other, so this one goes here, this one goes here. So potassium become positive, and sulfur become 1, 2, 3, 4, 5, 6, 7, 8, and the 2 negative. So 2 potassium to 1 sulfur, K2S. All right, I'll give you guys about 5 minutes to do the second one. Lithium and oxygens. So in case you don't have a periodic table, lithium is also a group 1. And oxygen is group 2. Oh, not group 2, group 16, sorry. It's group 16. So 5 minutes starting now. You can ask me any questions if you want. I have lithium, oxygen, lithium and oxygen. So lithium, lithium is Li. It's group 1, so I say it will lose 1 electron, become positively 1 charge. Oxygen will gain 2 because it's a group 16 element. It has 6 electrons already, so I would say it will gain 2, so it become -2. So again, it's the same ratio as before. You just time 2 for the lithium. Lithium, you have 1. Lithium, you have 1. Oxygen, 1, 2, 1, 2, 3, 4, 5, 6. And this one goes here. This one goes here. I have 2 lithium plus. And then oxygen. 2 minus. Okay, so it's lithium to oxide. Right, so the then goes, so the one on the top is potassium. Sorry, excuse me. Potassium sulfide. So here, sulfur, what you need to do is take the UR into ID. Potassium sulfide. Next, the second one is lithium oxide. Right. So because we know that lithium is positively charged, like 1 charge, and oxygen is -2. So when you actually write a compound, when you given the name and write the chemical formulas, you know that you will have 2 lithium because you need to balance off the 2 negative charge of the oxygen. Okay. So this worksheet has like 1, 2, 3, 4, 6 more. I will leave them as homework for you guys to finish in terms of ionic compounds. Any last minute like last questions regarding ionic compound namings, please let me know in the chart in the chat, and we're gonna move on to our next slide. Anybody want to try, like, let's just can we have somebody like try number magnesium and nitrogen? I'm gonna share a whiteboard. You know what? It's not good. Anybody want to try? Let's see. Sodium and sulfur. Anybody? Guys, you have to do the questions. We have to do the questions together. Otherwise, I wouldn't know whether you understand this or not. All right. I think you guys can just annotate the whiteboard directly. So do you want to give it a try? Joseph? Okay. Anthony, if you want, you can I think you'll be able to annotate it, right? Hold on. Let me see whether, oh yeah, good. Good. Okay.
Okay. Yeah, that's another way to represent it. Pretty good. Okay. Sodium. So right, perfect. Yeah, that's how you write a sodium sulfide. And Na2S. Right, perfect. This is correct. Very good. Okay. Very good. Next part today, it's still on ionic compounds, but here's about predicting the ionic compound using the combining capacities, also known as the crisscross method. So in the chemical formulas, you don't know, like by just looking at the name of the ionic compounds, you won't be able to know how many of which you have. You need to know their charge, right? But after you know their charge, there is a quick way of figuring out the ratio between them. And the metal is always written before nonmetals. So I have this 5-step really quick crisscross method. So the first step, if I'm so for example, I have sodium chloride. If I would write down the symbols of the elements, so I will put the metal first, so Na first, and then Cl. Okay, so you will be provided with periodic tables, and you'll be able to find those elements pretty quick once you get really familiar with it. And then write the combining capacity. So the combining capacity is just the binding, like the charge, the ion charge here. So sodium is group 1. Chlorine, chlorine is group 17. So we know that sodium is 1 and chlorine is -1, because sodium has 1 electron to donate. You will look like that. Chlorine has 7 valence shell electrons, so we have 1 space to accept 1 electron. That's how the +1 and -1 come. All right. So if if applicable, we can divide the combining capacity by the highest common multiplier, so it's easier. But here, because we don't, it's not applicable for this this pair, so we're not going to do it. So it's still -1 and +1. And then you just cross multiplying with you can you can ignore the sign here, because positive and negative doesn't really matter when you cross multiply them. So here cross, it's 1 and 1, so it's 1 to 1, and then you just drop all the ones and that's and the unnecessary brackets. So it's a rules in chemistry where the 1 is usually ignored. So if you see any symbols with like in the chemical formula of the compound names, if you don't see any numbers, that means there's 1. And same for the chemical, like the reaction equation. If you don't see the numbers in front of the chemicals, that means it's 1. So in chemistries, 1 is always dropped. Okay. So the name here is just sodium chloride. Remember INE switching to IDE. Any questions? No? Okay. No questions, right? It's it's very simple. It should be no problem for you guys to do the cross multiply here. So let's just see another set of examples. We have fluoride and calcium. Always remember, so fluoride and calcium, which one is a metal? Which one's the metal? Maybe, Teresa, maybe you can answer me which one is the metal here between calcium and fluoride. You can type the answers in the chat if you want. Okay. No answers? Right. So calcium is a metal, so we write calcium in the front and then fluoride at the back. The combining capacity for calcium. Calcium is group 2. Fluoride is group 17. So it has 2 valence shells electrons for calcium. So it can lose 2 electrons. So it's positive 2. And then for fluorine, it's in group 17. It already have 7 electrons on the outer valence shells, so it will gain 1. It's the step 3 is also not applicable, so we're gonna just keep everything down and then cross multiply. Okay, so positive 2 times 1, you have 1 calcium and 2 fluorine. The name goes calcium, which the metal's name doesn't change. And fluoride, INE changing to IDE. Any questions? No, no questions. Okay, last one, magnesium and oxygen. I'll give you guys 2 minutes to try magnesium and oxygens. I don't need to see the process. I just want you guys to post the answers in the chat. Everybody need to post their answers in the chat, so I know that you know how to do this. All right, magnesium and oxygen. Okay, 2 minutes. Okay. Time's up. Let's see the answers. MgO. Yeah, MgO is correct. Any more answers? If you get the wrong answers, or if you didn't get the answers, magnesium and oxygen. Magnesium is Mg, Very good. I see you guys understand it. It's very good. Magnesium is 2 plus 2 and oxygen is -2. So here you can actually cancel it out. So like you can divide them with the highest common multiplier, which is 2. So you make them 1, and it's just 1 and 1. So I'm not gonna do that. MgO, magnesium oxide, because 2 cancel out. Yes, so I could actually step if you wanted to do it. You can do, but it's not like very necessary. So it's a step you do might help you make reduce the chance of making careless mistake. But if you're really familiar, you see the +2, you see the -2, you know it's 1-to-1 ratio. So that one is the step 3 is definitely optional, but the other steps are kind of important, so have to keep track of that. All right. That's what we have here. So when you are predicting ionic compounds using the combining capacity here the combining capacity. So if you don't remember from grade 9, it's how many bonds one ion can one atoms can be able to formed with others. So it's depending on the number of valence shell electrons. Okay, so to check whether the formula is correct, you should figure out the sum of the ionic charge, and that sum should equal to 0. Like all the 3 we did, the sum adds up to 0. And remember, ionic compounds, even though it's called ionic compound, this ionic is referring to the ionic bond you find inside. All right, ionic bond, so it's the attraction between the positive and negative, positively, negatively charged ions. So it's that attraction. So this is the ionic referring to, but the overall the compounds should always be neutrals, and the charge should always be 0. Like all of them we do. So here you have sodium, which is +1. You have chlorine, that's -1, so equal to 0. And you have magnesium, which is +2. Oxygen is -2. You have +2 plus -2 equal to 0. So for calcium fluoride, it's +2. And then the fluoride is -1. But here, remember, you need to cross multiply this 1 and 2. So we have +2 plus 2 times -1. So you have 2 plus -2, which is 0. All right. So all the sums should be add up to 0. And this actually works for all the compounds. So no matter what you have in the future, so no matter it's ionic or molecular or even organic, which is the one you're gonna learn in grade 12, the charge will always add up to 0. When you see compounds, it's always 0 because it's neutral. If it's charged particle, it shouldn't be called compound. Okay. Let's do 2 more practice together. So I give you guys 3 minutes to finish this 2. We have potassium and oxygen, calcium and nitrogen. Again, you can post the answer in the chat after you're finished. All right. Starting now. Because we're 10 minutes late, so we're gonna be, the class will be end at 11:40. So still have time, 3 minutes, starting now. Okay. All right, see a lot of people finished. Yeah, potassium oxide and calcium nitride. That's correct. Perfect. Very good. Very good. Okay. Any questions regarding this? No? Yeah, we have, that's the answers. Nitride. So nitrogen is the following the same rules with oxygen. Get rid of all of that, and you have nitride. Okay. Anything. So here is the names and ionic charge of some anions. So notice that all of those four, those are halogens. You're gonna see them a lot because they are pretty much the most reactive nonmetals you have. And they are just like one step away from having the full valence shell. So they are really passionate about grabbing electrons from others, usually from metals. If you know, like if we learn, if you guys learn about the covalent compounds, so the covalence, so the molecular compounds, you know that halogens still behave really aggressive in terms of grabbing electrons, even though you cannot take the electrons, because in covalent compounds you're not taking and losing and gaining electrons, you're sharing electrons, but the sharing become quite unbalanced because halogens are really good at grab electrons. All right, oxygen and sulfur, they are from group 16. So this is group 17. But group 16s, they have 6 valence shell electrons and then 2. Nitrogen and sulfur, it's from group 15. So they have 5 valence shell electrons and they need 3. So the simplest, like to write it more probably. And that's how the name is changed. Fluorine become fluoride. You have oxygen become oxide. Sulfur becomes sulfide. Nitrogen become nitride. And phosphorus become phosphide. Just memorize it and keep it in your head. Like those names of ions, you have to memorize. Okay, so those things are not provided in the test. And if you spell it wrong, some teacher, if it's marked really strictly, will take the whole mark away if you spell it wrong. So be very careful. And another thing about it is you're gonna learn a thing called polyatomic ions. So polyatomic ions, you will have names really similar to sulfide. For example, you will have a polyatomic ion called sulfate. It's SO4 2 minus. Even though the charge are the same, but it has 4 extra oxygen. So it makes the whole element entirely different. Like it makes the whole compounds entirely different if it's from sulfate or sulfide. So it makes a big difference. So you have to spell it right. Okay, so that's about the anions, and those are all the non-metals. So for the metals, it's not shown here because metals doesn't change their names. If you have magnesium, it's just gonna be magnesium. Metal never changes its name. All right, no matter it's with polyatomic ions or regular anions. Oh, by the way, the polyatomics, so poly is means multiple, so many different and atomic is for atoms, so polyatomic ions means that you have an ions that have so you have an ions that have multiple different atoms. It could be the same, but most of the case it's different. So it's different. It's made up with different element. And most of them are negatively charged. So most of them are anions, but there are, I think, just one cation, which is ammonium, NH plus. Ammonium is a +1 charge. Everything else, I think, pretty much is negatively charged. All right, so just so last minute questions. Where does it go? So I will send this to you at the end of today's class. And there are a lot of practice here and there. If you have times and you're interested, you want to practice, definitely go ahead and fill this out. I will send this to Flora and she will send those documents to you guys through emails. If you have any questions, you can definitely ask her. She'll let me know, and I will. Or if you want me to check the answers, I'm happy to do that. Other than that, any questions before the class is dismissed? Final thoughts? No, we're all good. We're all good. Okay. Then this will be the end. Thank you so much for coming. Looking forward to see you guys during summer. All right, bye.